everyone, and welcome back to my YouTube channel Neuropedia Unlocking the Brain. In this video, we'll discuss Alzheimer's disease. Alzheimer's disease is a brain disorder that slowly destroys memory and thinking skills. It is the most common cause of dementia, which is characterized by memory loss, cognitive decline, and other cognitive abilities that interfere with daily life. Dementia is not a normal part of aging. It is the result of disease that damage the brain. When nerve cell gets damaged and the connection between them is lost, a person develops dementia. Let's talk about signs and symptoms of Alzheimer's disease, AD. The early symptoms of Alzheimer's disease are often mild and may go unnoticed. These symptoms include memory loss, confusion, poor judgment, mood changes, changes in mood or personality such as becoming withdrawn or aggressive, trouble in conversation with others, vision problems, social withdrawal, and difficulty in completing familiar tasks. Talk about what happens to the brain in Alzheimer's disease. The specific changes that occur in the brain are not fully understood, but two main hallmarks of the disease are the accumulation of amyloid plaques and neurofibrillary tangles. In this figure, you can see on the left side we have healthy brain in which normal neurons are present. But on the right side, there is the brain that is affected in Alzheimer's disease. Here you can see there is the accumulation of these amyloid plaques and the neuron is not healthy. And in this one, compared to this figure, the left figure, this right hemisphere of the brain, you can see these are the ventricles that are enlarged. So in the brain there are changes like expansion of the ventricles, and also the gyri are narrowed and the sulci they get widened in the Alzheimer's disease. Now let's talk in detail what happens to the brain in Alzheimer's disease. So here you can see this is our healthy brain, and on the right it's unhealthy brain due to Alzheimer's disease. So I talked about amyloid plaques. So amyloid plaques or amyloid beta. So generation of amyloid beta occurs or begins because of this protein known as the amyloid precursor protein APP that is found normally in the neuronal membrane. So here as you can see this is APP, amyloid precursor protein. Now why this APP is important? So it is essential because it is involved in repair after the injury, and it is also essential for the neuron growth. Now this APP needs to be recycled, and there are two major pathways that leads to the breakdown of this APP. So let's study one by one. So first pathway is the non-amyloidogenic pathway. In this pathway, these enzymes alpha secretase and gamma secretase, they sequentially cleave APP at certain regions to produce small fragments so the body can easily dispose of. In the amyloidogenic pathway, so this is the pathway that produces the amyloid beta. Now in this pathway, the beta secretase and gamma secretase, these are the two enzymes that sequentially cleave this APP protein into fragments and resulting in the production of amyloid beta monomers. So these are amyloid beta monomers, and these are proteins that are made up of up to 36 to 43 amino acids. This amyloid beta is normally broken down in the brain through phagocytosis by microglial cells and by receptor mediated internalization by astrocytes. Protease neprilysin is also important in the degradation of this amyloid beta. Now what occurs in Alzheimer's disease? In AD, the production of this amyloid beta is increased and there is a decrease in the breakdown of this amyloid beta, due to which the aggregates into oligomers, and they aggregate to the alternate form to a characteristic senile plaques. So they usually form the senile plaques, and these plaques that are formed, they can block the neurotransmitter in the synapse, and thus they can block the neuronal communication. Let's talk about neurofibrillary tangles, tau protein. Now inside the neuron, the microtubule comes together to form a cellular highway. So basically this highway is used to transport the cellular products from the soma to axonal terminal and vice versa. So this is the soma and this is the axon terminals. So this highway that is shown with red markings, so these are the microtubules, and these are connected, or these are held by these yellow thing that you can see here. So these are the tau that is important in stabilizing these microtubule tracts. So the transport, if it is from soma to these axonal terminal, so this transport is known as the anterogate transport. And if the transport of material is from axon terminals to the soma, so this type of transport is called retrograde transport. So in healthy neuron, these transport occurs smoothly. Now, if we talk about Alzheimer's disease, so in the pathogenesis of AD, the amyloid beta that we have already discussed, these activates an intracellular kinase that phosphorylates these tau protein, and once the tau protein they gets hyperphosphorylated, these detaches. So here you can see this detaches from these microtubules, and they begin to aggregate inside the cell to form neurofibrillary tangles. So these that I have shown here, they aggregate here and they form these neurofibrillary tangles. Now once this protein that is responsible for stabilization of these tubule, it gets detached and accumulates in this. So this disables the intracellular transport. So therefore we can say the intracellular tangles, they can disrupt the transport in the Alzheimer's disease. factors that are associated with Alzheimer's disease. The first one is age. The risk of developing Alzheimer's disease increases with age. Genetics. Some people have genetic mutation that increases their risk of developing Alzheimer's disease. Family history. People who have a family history of Alzheimer's disease are more likely to develop the disease. Head injury. People who have a history of head injury are more likely to develop Alzheimer's disease. Lifestyle factors. So some lifestyle factors such as smoking and obesity may increase the risk of developing Alzheimer's disease. Let's talk about the treatment. So currently there is no cure for Alzheimer's disease, but there are treatments that can help to slow the progression of the disease and manage these symptoms that are associated with the Alzheimer's disease. So if we talk about medications, there are several medications that can help to improve memory and cognitive functions in people with Alzheimer's disease. So these medications can be cholinesterase inhibitors, memantine. Others medications include antipsychotic drug, antidepressant. Non-drug treatment can also given to the patient that are suffering from Alzheimer's disease, and these includes cognitive training, behavioral therapy, physical therapy, as well as music therapy. So these therapies can help improve the symptoms that are associated with the Alzheimer's disease. Thank you so much for watching this video. For such more videos, like, share and subscribe my channel Neuropedia Unlocking the Brain.